Language. We use language to communicate with each other. We'd rather like to communicate with computers. Sometimes, it's hard to make computers understand what we want them to do. It'd be really convenient for all of us if computers could just speak with us and understand what we mean. In the field of AI, or artificial intelligence, this goal is called natural language processing. Let's define some important words. I'm going to teach you about parsing, which is extracting meaning from the structure of a sequence of words, like a sentence. Before we can start parsing, we need a lexicon. A lexicon is like the vocabulary for the parser. It's the list of words that our parser will be able to recognize and handle. I use the term word loosely. We can actually use whatever sort of symbol we want. If we just want our computer to understand how to do the job of a four-function calculator, we might get away with the numbers 0 through 9, the plus sign, the minus sign, the multiplication sign, the division sign, equals, and a decimal point. If we want our parser to speak full English, then we'll need the whole English dictionary. Next, we need a grammar. A grammar is the set of rules that tells how the pieces of the language, the things in the lexicon, fit together. Each rule is of the form left side, right side. We call the left side a non-terminal, and the words in our lexicon terminals. Each left-hand side replaces the sequence of terminals or non-terminals on the right-hand side. Note that there are multiple possible replacements for any given non-terminal. These rules also define a special non-terminal goal. For English, the goal is simply what you and I know as a sentence. The task of the computer is now to find a sequence of substitutions described by the rules, the grammar, that 1. Results in the goal, and 2. Uses all the words. Let's see how this works in action. We'll take a short sentence like, "May I buy the gift with a credit card?" We start by taking the words in our lexicon and mapping them into logical units. In this case, we used standard parts of speech. Pretend for the moment that these were substitutions described by our grammar. They're omitted on the right due to space constraints. We said that each rule described a replacement of the right-hand side with the left-hand side non-terminal. We'll make replacements in accordance with the rules here. Let's start by taking credit card, which is an adjective, followed by a noun, and replacing it with the noun phrase non-terminal. Now, we'll note that gift is a noun, and that a noun alone can also serve as a noun phrase, by the rule in the yellow box. So we substitute gift with noun phrase. We continue making substitutions. This time, we'll do the rule in the green box, replacing an article the and a noun phrase gift with a noun phrase. It actually applies in two places now, so we'll make the second substitution, making a credit card a noun phrase. Next up, we apply the rule in blue, which replaces with a credit card with a prepositional phrase. The orange rule makes a verb phrase from buy the gift with a credit card. Lastly, we use the rule in white to make a substitution that reaches the goal. We have now successfully parsed the sentence. You may be wondering how we came up with the order that we did substitutions in, and the answer is that I picked them randomly. The computer has to behave similarly, trying out all possible substitutions, many of which will ultimately run out of options or reach the goal before it uses up all the words in the sentence. When this happens, the computer knows it made an incorrect replacement somewhere, and it backtracks. It'll keep trying to interpret the sentence in different ways until it succeeds in finding one that's valid. But that's not all. There's a couple other problems that can arise due to the ambiguity of language. In natural languages, many sentences can be parsed in multiple ways. If you've been looking really closely at the rules, you might have noticed that when we made the substitution in orange, we actually could have made a different substitution and still made it to the goal state. Here's what the alternate sequence looks like. It has a slightly different meaning. Rather than using the credit card to buy the gift, this one interprets the gift as possessing a credit card. Both are technically valid interpretations of the sequence of words, but you and I know which one was probably meant by the speaker, the first one. Computers can use knowledge of likelihood from previous conversations, along with context clues, like other words or knowledge of the situation at hand, to determine which interpretation is most likely. That's parsing and syntactic analysis of context-free grammars. Hope you enjoyed learning, and thanks for watching.